Welcome back to Rationals with Janke for Pre-Calculus Math 11. We're going to take a look at adding, subtracting rational expressions with binomial or trinomial denominators. So last section we looked at adding and subtracting with monomial denominators. So let's see what happens. What's the difference when we increase the number of terms, shall we say, in the denominators? We can use similar techniques as adding, subtracting rational expressions with monomial. So that's what we did in the last section, monomial, and let me just write that that's one term. Denominator, when we want to add rational expressions with either binomial, so bi stands for two, learn how to spell, binomial, and trinomial. Now we could go up to 4 or 5 terms, that kind of stuff, but it starts to get a little bit bigger than we really need to do, and once you see it with binomial, trinomial, that kind of extends off to larger number. To determine a common denominator is useful to, again, factor. That's really a big theme in this year. All the denominators first, then consider the lowest, again, common denominator. So nothing much different from the monomial stuff, but let's take a look here. Again, we're going to talk about non-permissible values. That's kind of a theme through this whole thing. So again, in red, let me just quickly do some non-permissible values. A can't equal 2, and it also can't equal -3. Let's talk about lowest common denominator. Again, I think that's a good idea. LCD. In this first one, it's a little bit easy because they are quite different. In a binomial case, it's not just A's and A's and -2 and 3, it's A minus 2 is one chunk of stuff. A plus 3 is one chunk of stuff. So let's multiply. Here we have our A minus 2. What am I missing here is A plus 3 over A plus 3. And then we have A plus 5 over A plus 3. And what am I missing here is A minus 2 over A minus 2. So at some point we might have to FOIL. In this first example, we have a squared plus 3a from that side. And the second one is, let's FOIL that out. So a times a is a squared. Insides would be 5a minus 2a minus 10. And that's all over the common denominator of a minus 2, a plus 3. Now, I could FOIL out the denominator. I think I'm probably just going to leave it in factored form. It's probably a little bit easier to see. Certainly, let's add the tops. 2a squareds. We have 3a plus 5a is 8a, minus 2a is 6a. And we have minus 10. So 2a squared plus 6a minus 10, all over a minus 2, a plus 3. You could FOIL out that denominator to make it a squared plus a minus 6, but I don't think you really gain too much from doing that. So again, let's make sure we factor first if we have to, look for common denominators, and go from there. Question B, why don't you hit pause now and give that a try. We have x can't equal plus or minus 3. I get positive 3 from the first rational expression, and I get the positive 3, negative 3 from the fact that it's a difference of squares there. I know 9 minus x squared factors into 3 plus x and 3 minus x. We could probably see that. Let's factor this first. So that's plus x, and this is 3 minus x and 3 plus x. Now, x minus 3 and 3 minus x are essentially the same if we factor out a negative sign. So I think the lowest common denominator here is going to be x plus 3 and x minus 3. And the way I'm going to achieve that is, let me go for x minus 3 here. Certainly I have to multiply this by x plus 3 over x plus 3. And what I'm going to do is I'm going to factor out a negative sign from that 3 minus x to make it x minus 3. Let me just rewrite 3 plus x into x plus 3. And the top will be x. So really what I've done is I've changed this negative, or this adding between them, to a subtraction by changing that 3 minus x into x minus 3. So we end up with 4x plus 12 and minus x. And in the denominator, I have x minus 3 and x plus 3, which would be our difference of squares, which again you could write as x squared minus 9. But let's maybe just write it as 3x plus 12 over x minus 3, x plus 3. You know what? Leaving it like that isn't a big problem. You know, again, you could FOIL it out, but you don't really gain much from that. How does this differ when we start talking about maybe trinomials? Here we go. We have a trinomial denominator. You know, again, we got to factor a lot of these things. Let's do some of the factoring first before we talk about non-permissible values. I can pull out a 2 there. This factors into m minus 6. No, it doesn't. It factors into m minus 2 and m minus 3. I still have some factoring to do on the left-hand side here. This factors into a difference of squares, m minus 2, m plus 2. And on the right-hand side, or sorry, on the right-hand rational expression, that's what we get. So non-permissible values, m in this case can't equal 2 and negative 2 from the first kind of rational expression and positive 3 from the second rational expression. The lowest common denominator here is a little bit bigger. It has to have a 2 in it. It has to have an m minus 2, an m plus 2, and an m minus 3. So a little bit bigger, but you know what? It just happens that we can just multiply by, again, what we're missing. So let's write this out one more time. 3 over 2, m minus 2, m plus 2. What am I missing from this is the m minus 3 over m minus 3. Minus 2 over m minus 2, m minus 3. And what am I missing here is the 2 in the denominator and the m plus 2. So starting to get a little bit bigger, lots of room for small errors. If you go slow, shouldn't be a big problem. So just take it a little bit easy, take it a little bit slow. Let me multiply out this first term here, 3m minus 9 in brackets, and then subtract off. This 2 times 2 is 4, and it's still m plus 2. Let me leave it like that for now. I might going to have to FOIL that out, or sorry, expand that out in a second. There's our huge common denominator of 2, m minus 2, m plus 2, and m minus 3. We have 3m minus 9 in the numerator, minus 4m. That, again, that negative distributes. It's very common to make that kind of mistake. So minus 4m minus 8 over our common denominator. And really from there it's just a matter of gathering like terms. So let me take this and go off to the right here since I'm running out of room. So that's negative m and minus 17 over the massive denominator. So a lot of steps there. You know what? If you take it slow, go step by step by step, it shouldn't seem too bad. Remember, just always go back thinking about adding and subtracting regular old fractions. Same idea. So I have one last one here, which is kind of a little bit bigger. Why don't you hit pause now and see if you can give that one a try. I'll come back to non-permissible values and that sort of thing in a second here. Let me factor this first. X plus 2, 3 over, we have 15 is 5 and 3. Minus x, and here we have x minus 3 and x plus 2. So, again, trinomials in the denominator makes it a little bit bigger. We can see non-permissible values here fairly easily. X from the first rational expression can't equal -2, then 3 and 5, and 3 and -2 we've already covered. Our lowest common denominator here, x plus 2, it doesn't look like there's any coefficients. X minus 3 looks like one, and x minus 5. You know, it's a good idea to maybe take a look at the lowest common denominator, and it's probably a good idea to compare it to what x can't equal the non-permissible values, because that should correlate pretty well. So let's take a look here. We have a 2, we have x plus 2. What do we need to multiply this by? I think we're missing an x minus 3 and an x minus 5. So x minus 3 and x minus 5. This one's going to be a bit bigger. 3, x minus 3, x minus 5. That one's missing the x plus 2 over x plus 2. And finally, the x is missing the x minus 5, it looks like. Perfect. So a little bit of a hassle, I think, in the numerator here. We're going to have to FOIL a few things out. Let's see what I can do here. Let me take this FOIL job here of the x minus 3, x minus 5 first. So there's the 2. We get x squared. Negative 3x, negative 5x is negative 8x plus 15. We have plus in the second term 3x and 6, and minus x squared minus 5x. So quite a large numerator, and the three factors, I should say, in the denominator. So follow along here. 2x squared minus 16x plus 30 plus 3x plus 6 minus x squared plus 5x. Again, that negative distributes to both of them. And that's over our crazy denominator here. And just simplifying, certainly the numerator is going to become 2x squared minus x squared is just plain old x squared. How many x's do I have? I have a minus 16, I have a plus 3 and a plus 5, so that's minus 8x. And we have 30 plus 6 is 36. And that's all over our huge denominator. So again, really just equation or expression manipulation. Not a big deal about expanding that denominator. Again, expanding into a cubic kind of thing would be probably a little bit big. Our final little thing here is actually a word problem, and word problems are going to fall into a couple of types, and this is like a distance, velocity, time one. These ones I always like to draw some sort of picture or table. Farmer Lenny Leonardson had to drive 100 kilometers to get to the Big Bird auction with a truck full of ostriches. After the auction, because of an empty truck, he was able to drive back home 20 kilometers an hour faster than his initial trip there. Write and simplify an expression that gives Lenny's total travel time in terms of his average speed heading to auction. So this actually is quite important in terms of his speed heading to auction. That typically means, that tagline tells you that's what our variable is going to be. Let's call that x, is the speed to auction. Now we're talking about distance, velocity, time kind of thing if you think to physics. We are trying to look for, the question is asking for his total travel time. So what we're trying to solve for is time here. So if we divide by d, we get, or divide by v, we get time as distance over velocity. So this is where I like creating a little table. We have distance, velocity, time. We have to the auction and from the auction. So what do I know is that the velocity heading to auction is our x value. He had to drive 100 kilometers to get there, so it's 100 distance to it and 100 distance back. After the auction, because of an empty truck, he was able to drive back home 20 kilometers an hour faster than his initial trip. So faster would be his initial velocity plus 20. And this is where we figure out a little rational expression for time. Time, as we saw over on the side here, is distance divided by velocity. So distance is 100 over the velocity of x, and this one would be 100 over x plus 20. So that's a pretty standard distance velocity time type question. We can talk about his total travel time. Has to be his time there, which is 100 over x, plus his time back, which is 100 over x plus 20. This question asks me to simplify it. Again, we could talk about non-permissible values. X definitely can't equal 0. That doesn't make sense. You can't travel at 0 kilometers an hour. And traveling backwards, probably not going to work out when you're heading towards the auction. So let's leave it as that. Lowest common denominator is going to be x plus 20. So we have 100 over x. I need the x plus 20 here still. And we have the 100 over x plus 20, which needs to get multiplied by x over x. So this is a fairly straightforward question with common denominator of x plus 20. And what we end up with is a total travel time of 200x plus 2000 over x plus 20. So it's really dependent on how fast he was going. So that is total time. Now, it's really just an expression right now. Later on in chapter 8, we'll probably solve this. I'll give you an idea. Oh, let's say it took 10 hours, and we'll solve for x. But in this case, all I want you to do is to be able to write the rational expression. This ends the notes for adding, subtracting rational expressions with binomial or trinomial denominators.